Hello friends, in this video we are going to discuss about a relation between mass and velocity of a particle moving with a relativistic velocity. Okay, so before we start, please do subscribe the channel, hit the thumbs up button, also share with your friends, inspire me to create new contents for you and help me to grow my channel, and also hype the video if you get the option. And if you want to follow me on Insta, this is my Insta ID OJHALAKHYAJIT123. That's my Insta ID. You can follow me on Insta. So now let's start. So here you see, suppose we have two coordinate systems, or you can say two frames. So suppose we have two frame of reference. So here you can see like this. Okay, so give me 1 second, just wait. So here you see, so one is S frame and another is S dash frame. Okay, this is suppose here you see, this frame is S frame, this is S frame. Okay, this frame is S frame and its origin is O, and here you see, and this frame is S dash frame. Okay, so this is suppose Y, here it is Y dash, and this is origin O dash, and this S dash frame is moving towards S with relative velocity v, suppose with relative velocity v. Okay, so here you see, suppose let me consider two balls. Okay, one is thrown from this frame S, this is A, suppose this ball is A. Okay, and this is thrown with velocity u, and another ball is thrown from here towards downward direction, this is B, suppose, so its velocity is minus u, which is opposite, equivalent opposite to the ball velocity of the ball A. Okay, velocity of A and B balls are equals and opposite. Okay, are equal and opposite, and as this frame S dash is moving towards S with velocity v, and when these two will impact, okay, so now you see this ball B will be moving towards horizontal direction as well as downward direction also, and they will, you know, B is coming like this and also moving in this direction, and this is A, it is going upward. So that means this ball B is here you see, because this frame is going forward, right, this frame S dash is going forward, so that's why they will collide. Okay, they are going such a way that they will collide. Okay, this ball will come to this position in this way, and this ball A is going upward. Okay, so they will collide like this. Hope you have understood this. So now you see, let me write what I have considered here. So let us consider two systems, S and S dash. Okay, S dash is moving with velocity v relative to S towards the S along positive x direction. Okay, let me consider that way. And two balls, two identical elastic balls A and B are thrown with equal and opposite velocities, positive u and negative u, along Y and Y dash respectively in system S and S dash. Okay, right. So here you see that this ball A here you can see this ball A is thrown upward with velocity u plus u, and this ball B is thrown downward in downward direction with velocity minus u, right? So hope you have understood this. So along Y and Y dash, right? So now you see here. Okay, first pause the video and note it, and let me copy this diagram and let me go to a new slide. Okay, so here is the diagram. Okay, so now you see, so before the collision, before impact observed from the system S, So what we can write before impact, according to the rules of transformation of velocities. I hope you have watched the video that made on the transformation of velocities. If you haven't, then please go through the video, link is in the description box. Okay, so then you will understand. So now you see, according to the velocity components, or velocity components of the velocity, the components according to the rule of transformation of velocities, the components of the velocities will be given by velocity of A along x-axis will be 0, because this frame is at rest we have considered. Okay, so let me represent the velocity of A by UA along x-axis, UAX. Okay, let me represent, that's going to be equal to 0. And velocity of the symbol A along y-axis, that's going to be positive U. Okay, that's going to be plus U. And similarly for ball B, velocity of the ball B, okay, which is moving along y-axis as well as x-axis, right? So that's why this was for ball A, and now for ball B. So U B X along x-axis, this is V. That means with which this frame is moving towards X, because no additional velocity is given to B. This is the velocity. This is just allowed to fall in this system. As the system is moving forward, so it will be also moving forward, okay, with the velocity of the frame. Okay, so that's it. Okay, now along y-axis, its velocity will be UBY. That will be minus U root over 1 minus V square by C square. Let me explain why. Okay, let me write this one, just give me a second. Okay, here you can see. So hope you know this relations. So you must know this transformation relations. Okay, so that's why please do watch the video in the description box, because link is given in the description box. So now you see, when you take the y component, so here in this y dash is here minus u, this velocity, this is minus u here. Okay, and the uy, now here you see this uby, that means velocity of ball B, okay, along y-axis, which is relative to this frame. Now here compare this one with uy, and uy this is the velocity of B, that is relative to s dash. So in this case, this is minus u. Okay, so minus u is the velocity of B along y-axis, right? And here you see ux dash is the velocity of ball B with respect to, in this formula, with respect to this s dash frame. Okay, now here you see, actually in order to obtain the uby, according to this formula, we should take uby dash, right, root over 1 minus v square by c square divided by 1 plus v square by c square, and this should be ubx dash, right? So here this ubx dash is the velocity of the ball B relative to the s dash frame. Now here you see s dash frame is moving with velocity v, and B is also moving with velocity v because B is thrown in the frame S dash, right? So that means relative velocity between S dash and B must be 0 along x-axis. Okay, I am talking about x-axis. Now this frame, this ball is dropped in this S dash frame. This frame is moving with velocity v, so this ball B is also moving with velocity v. That means as both are moving with same velocity along x-axis, so in x direction relative velocity between B and S dash must be 0. So here we're gonna put 0, u dash bx will be 0, and along y-axis velocity of the ball B is minus u, so here we're gonna put minus u, right? So that's why as this becomes 0, so v square by c square into 0, that's becomes 0. 0 plus 1 is 1, and this divided by 1 is this, right? Hope you have understood this. So now let me clean these things. Okay, now let me write those results in the next slide. Now total momentum of A and B along y-axis. Okay, along y-axis in vertical direction. Let me take here, you see. So if ma is the mass of ball A and mb is the mass of ball B, then total momentum along y-axis. So m a u a y, and momentum of ball B will be mb u b y. That's going to be equal to, so may is plus u, and mby is this. So let's put these values. Then what we're going to have, let me write it properly, just u b y. Okay, now let's put the values of u b y and u a y. Then we're going to have m a u minus m b, because of this minus, this sign will be negative, u root over 1 minus v square by c square. That's what we have got, right? So this is the momentum before impact. Right, before impact. Now, sorry, let me write it properly. So what will be the momentum after impact, and total momentum after impact. Total momentum after impact. So total momentum, to find the total momentum after impact along y-axis. So what we need to do, first we need to find the velocity components along y after impact, you know. So for ball A, you know, it's this velocity u a y after impact, that will be, here it is positive after impact. Suppose these two balls are moving in opposite direction, equal and opposite direction. Okay, after impact they will change their direction. You know, it is coming with minus u, then after impact it will go with positive u. Similarly, it is before impact, if it is traveling with positive u, then after impact it will come with minus u, right? Hope you have understood this. So that's why here you see this is positive, so after impact it will be negative u. Similarly, for the ball B, u b y here it is minus, so it will be plus, right? That's it. So hope you have understood this. Now let me write it properly, just give me a second. Okay, so here it's gonna be positive u root over 1 minus v square by c square. Therefore total momentum after impact along y-axis will be, so now this is positive, it will be negative now, m a u, and this negative will be positive, plus m b u root over 1 minus v square by c square. That's what we're gonna have, right? So hope you have understood this. So now you see here, according to the law of conservation of momentum, linear momentum, the total momentum before impact and total momentum after impact must be equal, right? Let me copy these two results and let me write in the next slide. So let me copy this. So here is the total momentum before impact. This is total momentum before impact. You don't need to repeat, actually I have changed the slide, that's why I have written again impact, and total momentum after impact, so not before, after impact it becomes, so just we need to change the sign here, right? Minus, and this should be plus, right? So here is the result, this one. Let me copy this, just give me a second. Let me copy this, just give me a second. So here is the total momentum after impact, okay, right? So by the law of conservation of linear momentum, so these two must be equal. So we will get total momentum before impact, this must be equal to total momentum after impact, right? Hope you have understood this. So now, sorry, just give me a second. Okay, that's what we have got. Now you see, so let me rearrange all the things. Okay, so MAU, so bring this one to this side, plus MAU, and shift this one to other side, plus MBU root over 1 minus v square by c square, plus MBU root over 1 minus v square by c square. So adding these two, what we're gonna have, 2 MAU on the other side, 2 MBU root over 1 minus v square by c square. That's what we have got. So here 2 cancels, so we're gonna have MA by MB is equal to, so one more thing here, u also cancels, right, is equal to 1 minus root over v square by c square. That's what we're gonna have. Or you can write MB by MA is equal to 1 by root over 1 minus v square by c square, right? Okay, now let me copy this relation. Let me go to the new slide. Okay, so here you see, so this is nothing but relation between mass and velocity. Now let us consider that this particle A is at rest. Suppose at rest means, so here we're going to consider u is equal to 0, right? So as u tends to 0, then this mass of A tends to m naught means rest mass. Okay, so here we're going to write, if u tends to 0, then ma tends to m naught, which is rest mass. Okay, and the mass in motion let me consider this mb is m, suppose. Okay, mb tends to m. Okay, then this equation can be written as, so just let me copy this relation again, just give me a second. So here you see in this relation, this is v, not u. Okay, so v remains v here. So as u tends to 0, then ma tends to m naught, then this ma will be replaced by m naught. Okay, mb is replaced by m. Okay, then this relation becomes m is equal to m naught by 1 minus v square by c square. So this is the required relation. Right, so this shows that clearly the mass vary with velocity. Okay, this mass vary with velocity. From here you see, if velocity increases, then this quantity increases. As this quantity increases, then difference between 1 and this quantity will be very small. As the denominator becomes small, so this as a whole, this value becomes greater. Right, hope you have understood this. Smaller the denominator, greater the value as a whole. Suppose you have 4 by 2, you have 4 by 3. So here denominator is less, so this value is greater than this one. Here denominator is greater, right? So hope you have understood what I am trying to explain, right? So therefore mass of a body increases with increase of velocity. So mass of a body increases with increase of velocity. So thank you for watching. See you in the next video. Bye bye.